Dermatoglyphics. Welcome to AnthroNet Academy, a study aligned with the UGC NET Anthropology syllabus. Description box. Please visit the description box for books references. Dear learners, if you find this content helpful, please consider subscribing to AnthroNet Academy. Your support really means a lot and keeps me motivated to create more valuable content for you. Big surprise at 500 subs. Once AnthroNet Academy hits 500 subscribers, we're dropping something truly special just for you. A full video revealing 100 powerful, underrated, and must-read books list in anthropology. Complete with author names and insights important for UGC NET exam. The word dermatoglyphics comes from two Greek words, derma, skin, and glyph, carve, and refers to the friction ridge formations which appear on the palms of the hands and soles of the feet. Dermatoglyphics is the scientific study of fingerprints. The term was coined by Dr. Harold Cummins, the father of American fingerprint analysis, even though the process of fingerprint identification had already been used for several hundred years. All primates have ridged patterns on their palmar and plantar surfaces for better and easy grip. History. Fingerprints or dermatoglyphs consist of patterns formed by parallel ridges on bare skin of fingertips. They are typical for higher primates, but occur sporadically in other mammals. The dermatoglyphic patterns of dermal ridges that constitute human fingerprint are formed during early intrauterine life, between the 7th and 21st week of gestation, and are fully formed at about 7 months of fetus development. It is unique, and it will not change throughout the life of an individual. It has been reported that ridges are influenced by blood vessel nerve pairs at the border between the dermis and epidermis during prenatal development. Factors such as inadequate oxygen supply, unusual distribution of sweat glands, and alterations of epithelial growths could influence ridge patterns. The finger ridge configurations do not change throughout the life of individuals by environment or age factors except in events such as bruises and cuts of the fingertips. This property makes fingerprints a very attractive biometric identifier. Timeline. 19th century. 1823 January Evangelista Perkine, Czech classified 9 fingerprint patterns, coined the term papillary ridges. 1858, Sir William Herschel, India first to use fingerprints, handprints, for contract signatures in Bengal. 1880, Henry Faulds, Scotland/Japan published a letter in Nature suggesting fingerprints could be used for criminal identification. 1892, Francis Galton, England published fingerprints, establishing permanence and individuality of prints, introduced classification system. 1897, Edward Henry, India/England developed the Henry classification system still used in some countries. 20th century. 1926, Harold Cummins, USA coined the term dermatoglyphics, laid the foundation of modern scientific dermatoglyphics. 1936, Dr. Harold Cummins and Charles Midlow published Fingerprints, Palms, and Soles, a major reference in medical and biological dermatoglyphics. 1950s, 1970s, rapid growth of dermatoglyphics in medical diagnosis, e.g., Down syndrome, schizophrenia. Anthropology, population studies, kinship analysis. Genetics, studies on inheritance of fingerprint patterns. 21st century. 2000s, present. Dermatoglyphics applied in biometric security, neurolinguistic profiling, and learning style assessments, though the latter is controversial. Advanced computer-aided pattern recognition and digital dermatoglyphics for forensic and medical uses. Research continues into dermatoglyphics correlations with chromosomal disorders, neurological development, and ancestral lineage. Fingerball patterns. In dermatoglyphics, fingerball patterns refer to the ridge patterns found on the distal phalanges, fingertips, also known as digital patterns. These are the most commonly studied and classified ridge configurations in fingerprint analysis. Main types of fingerball patterns. There are three primary types of fingerprint patterns on fingerballs. 1. Loop. Most common pattern, 60-70% of people. Ridges enter from one side, curve around, and exit the same side. Types. Ulnar loop opens toward the little finger, ulna side. Radial loop opens toward the thumb, radius side. Key feature, 1 delta, triangular area where ridges meet. 2. Whorl. Found in 25-35% of individuals. Ridges form concentric circles or spirals. Types. Plain whorl has 1 or more ridges making a complete circuit and 2 deltas. Central pocket loop whorl, like a plain whorl but with a loop enclosing a spiral center. Double loop whorl, 2 loops combined in one print, like a yin-yang. Accidental whorl, irregular pattern that doesn't fit other categories. Key feature, usually 2 deltas and at least 1 ridge circuit. 3. Arch. Least common, 5% of people. Ridges flow from one side to the other in a wave-like pattern. Types. Plain arch, gentle wave-like rise in the center. Tented arch, sharp upthrust or spike in the center, resembles a tent. Key feature, no true delta, ridges flow continuously. Mnemonic to remember. LWA equals loop, whorl, arch. Loops love curves. Whorls whirl around. Arches arch like hills. Bonus. Diagnostic and anthropological relevance. Loops often dominant in general populations. Whorls more frequent in some tribal/isolated groups. Arches seen more in individuals with some chromosomal conditions, e.g., Down syndrome. Dankmeijer's index. Dankmeijer's index is a dermatoglyphic measure used in anthropology and human biology to express the proportion of arch patterns relative to whorl patterns on the fingertips. Interpretation. It gives the relative frequency of arches in comparison to whorls. A higher index indicates a greater prevalence of arches in a population. A lower index suggests whorls are more common than arches. Anthropological significance. Used to compare populations, ethnic groups, or individuals with specific syndromes. Helpful in population genetics, racial classification, and evolutionary studies. Certain populations show characteristic values. Caucasoids, Europeans low Dankmeijer's index, few arches, more whorls. Mongoloids, East Asians moderate index. Negroids, Sub-Saharan Africans higher index, more arches. Example calculation. Suppose arches equals 4. Whorls equals 20. Then Dankmeijer's index equals 20. Furuhata's index in dermatoglyphics. Furuhata's index is a commonly used quantitative index in dermatoglyphics and physical anthropology to compare the relative frequency of whorls to loops in a population. Interpretation. Higher Furuhata's index, more whorls compared to loops. Lower Furuhata's index, more loops than whorls. This index helps anthropologists distinguish between different ethnic or regional populations based on fingerprint pattern distributions. Anthropological relevance. Often used in racial and population studies. Caucasoids, moderate index. Mongoloids, e.g., East Asians often have a higher Furuhata's index, more whorls. Negroids, e.g., Sub-Saharan Africans, tend to have a lower index, more loops. Example calculation. Suppose in a sample, whorls equals 35. Loops equals 50. Then, Furuhata's index equals 70. Pattern Intensity Index, PI, Dermatoglyphics. The Pattern Intensity Index, PI, is a quantitative dermatoglyphic index that measures the complexity of fingerprint patterns across all 10 fingers. It gives a weighted score based on the types of patterns present, loops and whorls. Key points. Whorls are given a weight of 2, more complex. Loops are given a weight of 1. Arches are given a weight of 0, least complex. Index is calculated over 10 fingers unless otherwise noted. Example calculation. Let's say a person has whorls equals 4, loops equals 5, arches equals 1, PI equals 1.3. Interpretation. PI range 0 to 2. Higher PI equals more complex ridge patterns, more whorls. Lower PI equals simpler patterns, more arches/loops. Anthropological applications. Used to compare populations, assess genetic variability, and study population structure. Populations with higher PI tend to have more whorled fingerprints, e.g., East Asians. Lower PI is often observed in populations with more arches and loops. Summary table of common dermatoglyphic indices. Index formula purpose. Dankmeijer's index, arches/whorls, times 100 compares arches to whorls. Furuhata's index, whorls/loops, times 100 compares whorls to loop. PI, 2 times whorls plus 1 times loops, /10 measures overall pattern complexity. Thank you for watching. Please like, share, and subscribe to my YouTube channel, AnthroNet Academy, for more insightful content on anthropology. Stay safe and connected.